We're ScanLAB Projects. We believe that 3D scanning is the future of photography. We work with high-resolution LiDAR sensors to make precision-registered point clouds that can be used for science and art and communication. We've pointed our scanners at a ton of places with cutting-edge equipment that lets us see beyond the boundaries of our visual systems. And our co-founders are trained as architects, and they have a long commitment to environmental impact. This is them in the Arctic scanning some sea ice. And today, we're going to show you the results from a project that's 3 years in the making. We call it FRAMERATE. It's a novel way of making time-lapse cinema that also makes a scientific contribution. And we're going to start with a preview.
Can we pop the lights on, please?
We think this kind of work can be incredibly powerful as well as really beautiful. So, my name's Meriko Borogove. I'm a member of the ScanLab team and the executive producer of FRAMERATE. My pronouns are she and they.
My name is Trossell, co-founder and co-director of ScanLAB Projects. My pronouns are he, him.
And my name's Matthew Shaw, fellow co-founder, and my pronouns also he, him.
So today, our goal is to help you understand point clouds and their power is the future of photography. We're going to explain a little bit about how it works and how LiDAR works, and how it's different than traditional 2D photography. We're going to talk a little bit about how we scanned FRAMERATE, and we're going to talk about the things that we learned while we were making FRAMERATE, both in the scanning and the making of the work that you can see downstairs. Finally, we want to give you a sense of how to scan. And so we're going to show you some scans from iPhones, and then we're going to let you get hands-on and make some scans yourself. So if you haven't made a point cloud before, today's your day to make your first one. So I'm going to hand off to Will.
Thank you.
Turn to the desk.
Lights again, sorry. Thank you. So everything you see here is a real-life person, place, object, or event. And we digitize moments of the world using 3D scanning technology, capturing billions and billions of precisely measured points. And this point cloud is our medium. This is what we use to create our work. And over the last 10 years, we've been developing the technology and the tools to handle those enormous data sets and create immersive, engaging works from them. We've had the pleasure of collaborating with incredible people from all around the world, broadcasters, curators, scientists, making evocative and meaningful stories. And we've also been able to document amazing places, concentration camps across Europe, melting ice in the Arctic, and even found some Mayan temples deep within the Guatemalan jungle. So what is LiDAR? Well, we didn't invent it. This is NASA's model of the moon. It was first put to use on the moon landings. And it's also part of the way autonomous vehicles see the world. And increasingly, many of our personal devices are now equipped with LiDAR. And these are sensors that help map spaces and allow us to interact with them. And there's lots of LiDAR sensors out there. So we're just going to go through one of the ones that we more commonly use. It's called a terrestrial LiDAR, and it creates incredibly detailed point clouds of the world. And architects typically use these to measure buildings. It uses a spinning mirror here to guide the laser around the room. And in a single 360, which takes about 5 or 6 minutes, we're able to capture a room. And it's quite a phenomenal level of detail as well. As we zoom in, you can just about make out the detail here on the guitar strings. Once we've done that spatial capture, we add color via HDR panorama. And then we move our scanner around the building. So we move into his kitchen here, up the staircase, into his living room, through the hatch onto the roof, and then pop down into the street. And this puts together this incredible data set, which we can then navigate through or chop up, just like a normal 3D asset. And for us, these results are incredible because not only are they architectural model, but they're also so detailed that they become a measurement of life. That morning, we got all of his washing up, his dirty dishes. You could really tell what he had for dinner last night in this house. And for scanning, we find it's not just an improvement on photography, it's another dimension to photography. So here, this is one side of an incredible famous painting, which I'm sure you will recognize. But what you will possibly not have known is that directly on the inside of that building is a life support system holding up that wall with sensors, probes, and steelwork. And scanning's ability to show you that perspective is what is a sort of superpower for us. So we have outrageously detailed scans capturing static moments. But what happens when things move? Well, you get all sorts of funny artifacts. This is a dancer moving around the scanner as it's scanning. And much like motion blur, we get it, but we get it in 3 dimensions. So we have incredible moments of body and limb all dispersed around the scanner. We call this a motion blur. And we're really interested in exploring this in several projects. The other interesting element to get time into scans is to move the scanner as it's recording. And this confusing but hypnotic image is a piece of London that we scanned whilst bolting the scanner to Matt's car and driving it along. What we get is these amazing sausage buses. So as we stopped, the scanner kept on going. And afterwards, we elongate that data and we get incredible artifacts. As you can see, there's a white van and a bus. The other way of thinking about time is to keep the scanner still, but allow the world around us to move. And if we register all those scans back together and think about it as frames in a movie, we're able to move forward in time and capture some really dramatic and quite incredible events. This huge cliff fall made the BBC News back last winter. So, frame rate. What is frame rate? Well, it started with our ambition to take some of that elements of time and turn it into something as a new creative medium, to add time to our static scans. And all of this wouldn't have been possible without the support of Audience of the Future in UKRI, who really believed in our vision, and their support really allowed us to go deep, both on the technology required to do that, but also in the immersive communication of our art. We've been able to do that at several scales. So thinking about small things, people, cats, dogs, pelicans, ask me about that later, and really big things like landscapes. And across different times as well, like capturing the beat of a bird's wings is very different to catching the seasons of a forest. And we all wanted to do this with point clouds. And so to gather that data, we set about looking at very specific sites across the UK that would allow us to really see into some of these elements that we didn't know whether we'd see them or not, but we're hoping to capture as we went along. So for landscapes, that was really pushing our technology and our tools to the maximum. And we're very excited to bring some of that here to South by Southwest, and we've got an exhibition through some of that upstairs. So we'd love to see you there today with that. And the first sites that we chose were natural, based in Norfolk, and designed to try and capture the seasons as they unfolded across a year. We've got blossoming gardens, but we've also got beaches as well. We wanted to see whether we could capture the movement of tide and silt across Norfolk's beaches. And also these cliffs are receding at several meters per year, so almost like the perfect test case for us to measure that change. But we also took a shift later this year to look at Glasgow and focus our attention on man-made changes and put that into juxtaposition. So in Scotland, we've got urban locations where humans are the causes of changes, both within our consumption of our modern world, extracting materials out of the earth, carving holes. This is an incredible site where basically a mountain is being disappeared on the back of lorries. Or the recycling of waste as well is a very important feature of what's going on right now. And we call these locations our long scans. So we're scanning every day for 6 to 12 months. Each scan takes 10 to 45 minutes, depending on the resolution, and can be anywhere between 40 million points for a single scan up to 400. The high-frequency scans are where we try and do that repeat as fast as the scanner will allow us. So if you think about taking that scan every 4 minutes instead of every day, and so we've got locations like Glasgow's Central Station, and also the Forestry Commission have a huge site in Scotland where they're harvesting trees for all sorts of uses for pulp. So it's an incredible moment seeing this come out of the forest and towards you. And so just to give you a bit of a sense of what we're dealing with and what the data looks like, here's that beach that I was showing you earlier. And this is about 600 meters of beach, and the cliff is about 15 meters high. And this contains 500 million points. And if you keep your eye on the platform, you can see where we scanned. There's a little blind spot beneath the scanner. And as we zoom in and go further, so that rock is about half a meter across. There's about 100,000 points. So that's sort of 1 or 2 millimeters between those points. And if you think we've got the entire beach at that level of detail, it's like walking through another world. So I hope you all have some stats. So the precision, 1 or 2 millimeters. The scanner's got a range of about 400, 500 meters. Our longest scan is about an hour. Our shortest, as I was saying earlier, is about 4 minutes. And so just straight data off the machine is about 50 terabytes, and that multiplies by about 10 by the time we've copied it, processed it, and changed it. More stats, here we go. 1,800 scans in Norfolk, 2,900 scans in Glasgow. High-frequency scans, which we've done at Pub and various other amazing locations, so that's 700 scans. So that gives us a grand total of 5,400 scans, which is a fair number of hard drives. Other stats, Norfolk is roughly 1 to 2 billion points per day. So that's 365 billion points a year. Glasgow slightly less, being 6 months. So our total frame rate so far, and we've only got started, almost 500 billion, or over 500 billion. And just to give you a respect of like millions to billions, because it seems such an easy leap, but I'll give you a quick analogy. If I was to give you all £5,000 a day, you'd all be millionaires in about 6 months.
Yes, please.
Yeah. But to get you all to billionaire status, I would have to keep going for 550 years before you're a billionaire. So that's just how big things can get quite quickly.
Seems like those billionaires should give away some more money.
Good suggestion. So I'm going to hand over to Matt for our next chapter.
Thank you, sir. So I'm going to talk you through some of the results that have come out of the FRAMERATE project. And we're going to break these down into a number of headings. First of all, how this project has influenced our creative practice, some of the technology and tools that we've built, some of the science that other people have been able to do with the data that we've collected, how we've really taken on board the challenge of sustainability across this work, and finally, how we see this project and the potentials for use as a communication tool through the artworks that we make. So first of all, our creative practice. Actually, myself and Will have been scanning for so many years that it's kind of inherent in our brains operating in this kind of three-dimensional space. But for many of the people that we work with, that transition is slightly more abrupt. In particular on the FRAMERATE project, it's really important with us to collaborate with local photographers to go out and do the daily scanning with us. And so that shift from a 2D practice to a 3D practice is something that's been really, really interesting. I'm actually going to hand over to Kunal, who's one of the guys who's been working up in Glasgow with us on FRAMERATE over the course of 2021 to get his take on this.
I'm Kunal. I'm a photographer at ScanLAB Projects. I've worked on this project FRAMERATE for the last 4 months in studio, and I was on site scanning in Glasgow. Traditionally, I'm a photographer using 35mm film and medium format film, and I've transitioned to 3D scanning since I started at ScanLab. Initially, it was a pretty tough challenge and really interesting. Firstly, to get my head around a 3D scan, which I've never done before, and I think I definitely had a moment when I saw a scan for the first time and my jaw kind of dropped at how amazing it was, and just something I'd never ever seen before, and it was such a beautiful aesthetic that I hadn't come across before. I guess one of the big things for me to get my head around was that I wasn't capturing a light source, as the scanner emits its own laser with a light source in that laser, so it was a different method of thinking for me in order to capture what I wanted to capture.
And when people see FRAMERATE downstairs especially, they ask how we got these shots. I think Kunal's going to do a really beautiful job here of explaining the different ways that you work when you're thinking about taking a scan.
The biggest challenges were looking through the scanner's eyes almost, as I would with a photograph, in terms of what would cast a shadow. As a normal camera, you want to frame your photo so that you're getting everything you want in. With a scanner, it's capturing data, so missing data appears as a shadow, it looks black, but it's there's nothing there in the scan. So that's really something to take into account, where you're placing your scanner, what height it's at, what it's looking at. And then another big challenge for me was weather. In traditional photography, you can sort of battle the elements, you can work around the rain, you can work around the fog. With the scanner, however, we really struggled in Glasgow with a lot of rain, and also at some of our sites, in particular the quarry, in the morning there'd be a really thick fog, and the laser scanner couldn't go through the fog. So a lot of these scans came out unsuccessful. And in heavy rain as well, there was a lot of noise picked up as the laser from the scanner physically hit the raindrops or the particles in the air and wasn't able to capture what it needed to capture. So that was definitely a big thing to think about when I started.
Kunal's doing himself and the other people out scanning a little bit of disservice there, because they battled wind and rain every single day. The success rate on scanning actually is about 95–97% depending on their locations. When you bear in mind that the guys Brad and Paul who scanned the beaches for us were doing a 45-minute walk by themselves along the beach with about 40 kilos of stuff on their backs, setting up scanning for 3 hours and back. That was changing every single day depending on the tide times as well, so they'd be out there at 4 o'clock in the morning sometimes, and he says they failed a few times, but they really only failed a couple of times. It was absolutely amazing, the commitment from those guys. We'll talk a little bit about some of the tools that we've been able to make now over the course of the Audience of the Future funded project, so over the course of the last 3.5 years. And actually, the first of those, as Will mentioned, happened on a small scale. So before we started the FRAMERATE project, capturing movement on the scale of a human for us meant a single sensor, and it gave us back data that was jumping all over the place. Sometimes it'd be 17 frames a second, sometimes it'd be 30 frames a second. It was messy, it was almost kind of unusable, really. Just gonna get that film playing again there. There we go. What we've been able to do by the end of the FRAMERATE project is sync essentially as many sensors as we can get our hands on simultaneously. You're seeing 7 sensors here capture this dancer at the same time. That is delivered to us in a robust frame rate, sometimes up to 60 frames a second. So that's data that we can really robustly work with. We can sync audio to it. We can take it into a kind of high pressure production environment. And we've done that over the course of the last 1.5 years on some really serious film production sets where, you know, every minute is costing tens of thousands of pounds, and we've been able to operate in those sort of high pressure situations knowing that the tools are up to the job nowadays. And on the large scale, well, we've really enabled ourselves to operate with these massive amounts of data. Actually, one of the first things that we've had to do is just compress this data to be able to move it around between computers. Just to get a site onto a computer to render it is quite a phenomenal challenge in the first place. But we've got to the stage of rendering these point clouds in really beautiful detail offline, but also in real time as well. So you see the results of this here. We're able to render not just the entire beach, so this is our 600-meter stretch of coastline that Will was talking about, but we can also zoom in and do shots of the individual movement of pebbles on the beach there as well. This is all pre-rendered content. Our installation downstairs, FRAMERATE, is all pre-rendered content, but we also have this running in real time on handheld devices, on headsets. To talk a little bit about some of the science results that are coming out as well. This has actually been one of the most beautiful moments for me in the whole of the FRAMERATE project. When we were initially looking for locations to scan, we took a whole load of advice from a series of experts in the field about, for example, where on the UK coastline might we observe the most steady rates of erosion. This location, Haysborough Beach in Norfolk, was one of the places that scientists suggested to us. And when we showed this visual to them, it was just incredible to watch their reactions, because this is a diagram that they've been drawing for years. They've been sketching out. They knew this was happening on the beach, but they'd go down to the beach on an individual day and they couldn't evidence it. They couldn't see it. What they're really interested in is this little wobbly line, the relationship to this wobbly line and the beach and the cliff falling in the background there. And basically that wobbly line dips down, the cliff gets exposed and it disappears. And we've had so many moments with them seeing this data. We've given them a little bit more freedom to operate with that data as well. This is them in VR with a headset on. We're giving them some kind of basic analytical tools, comparing the way that the beach has moved. We're missing a few loops here. Let's get that going again. Comparing the distance that the beach has moved from the first day that we scanned to the day at which they choose here. So they've got control over time. They've got control of zoom. They've got control of their perspective on the beach. And I'm really, really proud to say as well, this is something that's taken a lot longer than I expected, and that's because scientists are much more rigorous people than us, I think. But our first paper is just about to come out in the journal Nature Scientific Data. The data that accompanies that is also being published for public use, and it's in a NERC public data repository, and that's Nature's gold standard for data going out into the public realm and being used by other researchers. What's amazing about that is that it means that this research doesn't just come from people who are only focused on a kind of creative output. It's got up to a standard where scientists can reference it in their papers and they're kind of confident using it, and that means an enormous amount to us, you know. Okay. We're actually really grateful, in particular in the latest round of Audience of the Future funding that we received, to have been able to focus on sustainability so much on this project as well. You know, the basis behind this project for us is reflecting on our relationship to the planet. That's the kind of subject matter that we're observing here. But to be able to reflect on the way that we make the work as well and the way that we operate as a practice has been really, really an incredible gift for us, really. And it's been really brave, I think, of Audience of the Future to allow us the funding to do that as well. So what have we done? Well, first of all, we've considered our values together as a studio, and we've used them to craft a studio policy. And in 2021 in particular, we focused really heavily on reducing the carbon footprint of our studio, but also the carbon footprint of this project. And I'll go into the details of that in a second. One of the things that I've actually most enjoyed about the sustainability work is a decision tracking tool that we go through almost every production decision now. We write down the decisions that we've made, but we also write down the better options that were out there at the time and why we couldn't take those better options. And quite often it's time or money that are influencing whether we can't make those better decisions. If we've thought about them previously, recorded them down, as soon as we've got to make those decisions again, we know how much time we need to give to be able to make better decisions. So a couple of the working truths that are coming out of this. Everything we've done is imperfect, and that's quite hard for us as well. We're quite precise kind of people who like to present things finished. That's never going to happen with the sustainability work at the moment. We have to kind of accept that it's always going to be a work in progress. And actually, you know, we discuss this now as a studio all the time. We kind of struggle through it. It's somebody's active role in all production meetings to flag the impacts that we're going to have. And you know, we're applying this kind of design logic that we have to this. It's okay to be scrappy the first time we do this. It's better to be scrappy and do it, and then the next time get a bit better, and the next time get a bit better again. So let's give you some of the numbers that have resulted in some of this work, because everything I've just said is words really at the moment. So the first thing that we're going to talk about here is the setup impact that we have. So this is the impact of us recceing locations, of installing, of getting ourselves set up to scan every day, of training up the members of the team who are going to work with us in these locations. We've been able to get our CO2 equivalent output per mile down by 30% on those. That's quite impressive, in particular because, you know, Norfolk's only an hour and a half up the road from us in London. Glasgow is literally the other end of the United Kingdom. So we're pleased to have been able to take that down by 30%. This is the daily running impact. So this is what the emissions that we have per mile in going out and doing those daily scans. We've cut those down between Norfolk in 2019 to Glasgow in 2021 by 95%. That's a big part of that is spending a lot more money, hiring electric vehicles for the extent of the project, but also completely reconsidering what's viable in a day to scan, planning our routes around environmental efficiency. And we can compare the overall project as well, but we're not really comparing apples with apples here. It's interesting nonetheless to see that the impact of the Glasgow project is significantly less than the Norfolk project. But actually to try and compare those things like for like, what we've done is we've taken the practices which we were using in 2019 and applied those to all of the processes that we went through in Glasgow. If we'd been operating on our kind of 2019 principles, there'd have been over 6,000 kilograms of CO2 equivalent emitted. We actually got that down to 1.2, so that's an 80% reduction in the impact of the project between those two periods. And that couldn't have been done without Audience of the Future being really bold at funding that, and also acknowledging the fact that we were going to be less efficient in our spending there as well, right? We regularly spent more money to have less impact. So yeah, it's been a fantastic kind of a learning place to go there. So what's come out the end of this? Well, our studio policy, this decision tracking tool, which we'd really love to talk to people about. There's some sensitive information in that, so that won't be going out public in its current form, but we hope to get a public version of that published pretty soon. We've noticeably reduced our impact in Glasgow, and we will be reporting the results from our studio and the results from FRAMERATE very publicly, pretty much as soon as we get back from South by Southwest, after we've all had some sleep. And the final element of the results here, one of the most important things for us, you know, we see all of our projects as artworks, and we believe artworks can do a really phenomenal job of communicating. So this is a little bit dark in this room, but how this work meets our audience is crucial to the impact that we think it has. We don't just want you to see the world in a completely new way, but we want to transport you deep inside the data. We want to take you out of the daily kind of hustle and bustle of life, I guess, and we want you to think on another time scale, on geological time, on seasonal time, on tidal time. We invite you to bear witness to the micro changes inside these data sets. We want you to walk along and use your body and find the details that exist within this work, but we also want the work to flood over you and fill you with a sensation. So some of this is on show downstairs in the 4th floor in the Verbena room at the moment. And we would really encourage you guys to come and lie down on the floor and relax in there. There we go, there's a little map. Just down the escalators, lots of signs. I'm going to hand you over to Meriko.
Thanks. So, the future of scanning. We started with this sort of bold statement that 3D scanning is the future of photography and cinematography. And I really believe that in 20 years, kids aren't going to understand why all of the photos in movies from right now are flat, kind of in the way they walk up to televisions and start touching them and don't understand why nothing happens. So it is bold, but the pervasiveness of 3D data in the world right now is accelerating madly, right? It's coming forward in a ton of ways. There are so many cars moving around the world. They are collecting data for Apple Maps, for Google Maps. They're collecting data that's powering all of the automatic lane keeping that are in safety features in cars today. And they're working on the research on how we're gonna have autonomous transport in the future. And it's interesting from a computational perspective, because we're pushing machine learning and computer vision at a rate and in ways that is climbing every day. We're approaching a Moore's Law moment like we did about 20 years ago in the graphics world. And so we did a project with the New York Times a few years ago. Can we drop the lights for this? And it's called The Dream Life of Driverless Cars. And the New York Times was writing about autonomous cars, but they realized nobody had an understanding of how a car might see the world around them. And we think that's really important, right? You should know how you're being filmed. You should know how you're being looked at. And so we made this movie, the Sausage Train and Bus was from this project. And it's beautiful, right? And it's really interesting to think about how a machine might see the world. But we're still talking about data as a tool, right? This is us trying to show humans how machines use data as a tool. We said the future of photography and cinematography, which is how we make art, is people. So we'll go back to cameras, right? They started out big, they started out slow, they started out really difficult to process. In fact, these very big cameras, you could only take very small photos of them at the time. But they made beautiful images, right? This is a picture made by Carlton Watkins of Vernal Falls in Yosemite National Park. I'm particularly fond of it. This is the national park that I grew up hanging out in. And a lot of photographers worked with some of the earliest film cameras in Yosemite National Park. In 2016, we went back to Yosemite, and we took our big, slow, expensive scanners, made a lot of data that's hard to process, and we made a new, beautiful work. It references and builds on some of that early work with cameras, hopefully in a more respectful way to the people and the land around there than those folks did. And I mean, we know now what's happened to to professional grade cameras over the last 13 years, right? We brought DSLR quality photos to all of you, and we put it in your pockets. We also brought the ability to process and work with in a professional cinematographic way to all of you in your pockets on those same devices. And I know a little bit about that. I was at Apple for 22 years, and I created the cameras and the camera teams for your iPhones. So here we are now, right? We have these 3D, with 3D depth scanning. We have these scanners that are on the back of the last 2 years of Pro iPhones, both the iPhone 12 and the iPhone 13. Yep, they're on the back of the Pro iPads. We have these brand new pieces of silicon that have all of the maths built into them so that we can do the kind of processing directly on device that accelerates all of that. And so it's much like the first few years of iPhone though, right? Those LiDAR scanners on the backs and on the fronts of your phones are lower resolution. They're a little bit slower. They don't have quite as much precision. But lo-fi is still art, and it's still science, and it's moving forward at a really accelerating pace. When we were working on the first iPhones, we really intentionally changed our language away from good cameras and bad cameras and started referring to them in our practice as big cameras and small cameras. And I think it's really useful to look at that frame today. I also hear the teams at Apple are still using that framework. So, to talk to you a little bit about what you have on your phone, the one on the front facing isn't just for Face ID. It's not just for unlocking your phone. Creative teams are using it every day right now for their creative practices. The Unreal Engine team made something called MetaHuman. You can use that camera, and you can make virtual productions. You can even make live virtual productions. The Royal Shakespeare Company, last year in March of 2021, did a really beautiful piece of work called Dream with world-class actors. Over 65,000 people saw these performances over 8 days, so it wasn't just a little experience. It was something pretty big. And lucky for you, you can hear from them. They're the talk right after us. They're also talking this afternoon here, and there's an extended performance with even more demos tomorrow in the Cedar Street Courtyard at 10 a.m., I believe, right? Yes. Brilliant. So you should go check them out. We have an actor from that. We have the motion director, and we have a producer, and they're talking about how they worked with these technologies as creative practices. So I said it's lo-fi. This is a movie. I was lucky enough to go to Mexico City in November when numbers were pretty good. I was sitting right across from my friend Jean. I didn't get up from my seat. This is sort of a little bit of a buzzy movie because I'm just using the app that you're going to use in a minute and screen recording it. So we don't have the tools to really make a beautiful movie, but all this data is pretty great. The piñatas were out for the first of Christmas. And without moving, you can see the little black hole where I was standing. But you really get a sense of the space in a way. I put these on my Instagram, and I was also shooting with a Leica, because I'm a photographer as well. All anybody wanted to talk about were the 3D scans on my Instagram, not my Leica pictures, which were pretty good. And I can't ever resist a one more thing moment. So I want to talk to you about some work we did in FRAMERATE in 2021, and this is brand new that we're talking about this. So we took our scanners, both big ones and small ones, to an auto shop, and they let us scan them, taking a car down to its component parts. And we did it both with our big Faro scanners, and we did it with our iPhones. We did it on tripods, and we did it with our intuition and our expertise. We also set some iPhones out with some journalists to the COP26 protests with just a day of here's how it works, and asked them to do some interviews with those as well. But today I'm going to show you the first looks at that work we did in the auto shop. And we're excited because we've never shown it to anybody before. So special preview for Audience of the Future and South by Southwest folks, and we're super excited. So we'll start. This is the Faro scanners. Can we drop the lights? So this is, you can start to see this aesthetic. It's looking familiar to you. And here's your iPhone. Are you surprised? I was a little surprised. I know my iPhone cameras, and I was a little bit surprised at how good this is. But really how you want to look at this is in a split screen mode, right? This is 3D data. We have a 3D world, so we can put our camera. It's really easy for us to make you a really beautiful split screen movie. We left the Faro in black and white, and the iPhone is in color, so it's really easy for you to see the difference. And I think the results are pretty interesting. Just gonna let you watch it for a minute. I think you can see where this is going. We certainly see where it's going. The work on the right was made with something that sits in your pocket every day. So, do you guys want to make some scans? Yeah. Amazing. So, before Matt gets started, he's going to get set up, but Kunal had a little bit of advice, because he did this for the first time, and it's interesting.
I think just have a lot of fun with it, and
texture.
the possibilities are.
Try that again. Oh.
Where's he going?
Did you unplug me?
I did.
All right.
I think just have a lot of fun with it, and the possibilities are really endless, especially now with the scanning on iPhones, making it more accessible to everyone. Just go out there, have fun. If you have an idea, just give it a go with your iPhone, and play around with angles and play around with different textures as well, because that's another thing. We're using LiDAR scanning, and that I don't know the word, that picks up textures on the surfaces rather than the light bouncing off a surface, which a normal camera would do. So it's interesting. Try and change your thinking and the way you take a photo, and try and understand how your creativity could affect the way that you could now take a photo with the new iPhones and LiDAR scanning.
Awesome. So we're going to use two apps. One is called Sitescape. It's a little bit more tuned for sort of static room scale things. You can certainly query it just like we've queried the big LiDAR scanners and move people through them if you like. And then the other one is called Record 3D, and that's really meant for volumetric capture of people doing what they do, move. We'll have these on our phones. Matt's going to do a quick little show so that you see how the user interface works. And then we'll all join outside. So.
Sorry, what was the second one?
Record 3D.
So you got them up on the screen here. So I'm actually going to show you guys Sitescape first. So Sitescape is an app that we would use for scanning a static subject up to the scale of about a room this sort of size. I'm just going to tap to start here, and then what we're going to do is we're essentially going to paint the room with this device. Okay? So we move the scanner around. We want to get behind something, get behind it. It's got quite a good range, we're seeing to the back of the room there. I'll stop that recording, tell it it's complete, and there's our 3D scan. This is like Meriko's Mexico scans. It's that quick. It's processed. You can navigate around it on here. It's a little bit fuzzy, but bear in mind when we do a LiDAR scan, we're doing that from a 60,000 pound piece of equipment on a steady tripod, and it takes us, fair bit of time to process those. When you guys have a play with these, we're going to ask you to save them, give them a name, ideally your name, so that we can share them with you afterwards. And if you want to grab them from us downstairs at our exhibition, then you're welcome to do that. So that's Sitescape. There's a whole bunch of little features inside that we can go through in detail in the demos. The next one that we'll show you is Record 3D. So Record 3D is the one that we use for moving things. In this instance, moving people. There's two settings on it. We can do really detailed moving faces, or we can do moving full bodies. So we're going to do a bit of moving full body stuff now. So give us some moves, guys. Let's have a little bit. That's nice. Okay. And we'll have a little look at that one. It goes straight into our library. Again, I'm going to ask you to do a bit of admin first of all, and just name them. Beautiful room.
Thank you.
You're welcome. And then here we go. Moving full body stuff now, so give us some moves, guys. So a little bit, that's nice.
That's great.
Okay, bit of moving full body stuff now, so give us some moves, guys. So there we go. I don't know if I can take the volume down so I can actually speak. No.
Why don't
Can
you
we
just
take
unplug and
that
I'll
down?
plug back in.
A little bit, that's nice. So we're going to take you guys through those. Come and join one of the three of us. And it's still playing on here. And I guess the thing to say as well is, you know, this is early days, just have experimental fun with it. We take the data off some of these sensors and a few other tools that we're using, and then we kind of dive them into some of the production workflows that you've seen that creates the final visuals. But really, there's a whole bunch of emerging tools for getting this data and playing with it in Unity, playing with it on your own phone. So I hope you guys have fun.
So I'm just going to jump to here, because we're all going to go outside and we're going to let them reset the room, so we'll finish up out there. But just thank you for coming early this morning. I know it's early, especially at South by Southwest. We are giving this workshop again today at 2 o'clock and tomorrow at 10 a.m.? Tomorrow morning, it's in the schedule. We'd love to have you send your friends. We also have this really incredible exhibit downstairs, just one floor down and almost cat-a-corner to here. So if you'd come by, I think you might really enjoy it. So thank you for being here. Any other words, my friends?
Not at all, let's have fun.
Amazing.
Get together.
Let's head outside.
See you later.